Identifying proof. Sometimes a proof is presented that's invalid. Reasons could be an incorrect assumption. You just assume, you made an assumption that something was true and it's not. False statements within the proof. The statement that there's a mistake, right? And we'll ask that, right? Where does the mistake occur? Somebody made a mistake. Here's their proof. Error in reasoning and circular reasoning, right? Just going around in circles, saying, well, this and that, and it just takes you around in circles. You don't get anywhere. Okay, let's look at it. Example, students that like mathematics take physics. Johnny likes mathematics, therefore Johnny must take physics. What's the error? Okay. Yeah. Well, it could be this. Students that like mathematics take physics. Yeah, they like math. That doesn't mean that they take physics, right? So we cannot say, just because Johnny likes mathematics, it doesn't mean he's going to take physics. We could say, all students that take mathematics must take physics. Johnny takes mathematics, therefore Johnny takes physics. That would be valid, right? So, yeah, incorrect assumption, right? You're in the courtroom, they'd say, you're assuming facts not in evidence, right? Like, we don't have anything to back that up, so. If A plus B is equal to C, then the following proof shows that 3 equals 4. Explain each step and find the error. Okay, so we start with this. This is our statement, right? If A plus B is equal to C, we're going to assume this is true, right? A plus B is equal to C. Then, okay, so if I take 4A minus 3A, what's that equal to? 1A. If I take 4B minus 3B, what's that equal to? 1B. If I take 4C minus 3C, what's that equal to? C. So that should be the same then, right? If I take 4 times the number and subtract 3 times the number, I'm just going to get the number, right? So what's going on in this step? Well, we took 4 times each number. Each number. And subtracted 3 times. Each number to get back the original number, to get the original. Sorry, let's just say which gives the original number. Okay, so assuming they're not all, well, if they're all 0, that's going to be true, right? 0 plus 0 equals 0. But, if A is 10, I'm going to get 40 minus 30, which is 10. So if A is 5, I get 20 minus 15, which is 5. Okay, I can see that's true. What if A is negative 10? I'll get negative 40 minus negative 30, which is negative 40 plus 30, which is negative 10. Okay, so I'm getting back the original number. Okay, so far so good. There's no error here. So what are we doing here? We got 4A plus 4B minus 4C. Is that legal? So I got 4A plus 4B, and then I'm moving the 4C over. So this would be true then, right? And then I moved the negative 3A over here, became positive 3A. I moved negative 3B over there, became positive 3B, and I'm subtracting 3C. Okay, so what have we done? We removed the brackets, I guess. And what did we do? We subtracted 4C from both sides. Subtract 4C from both sides. And we added 3A and 3B to both sides. Subtracted 4C. Okay, so the 4C moved over, right? So we subtract 4C from this side, gives us 0. Subtract 4C, we got minus 4C. Subtract 4C from both sides, and we added 3A and 3B to both sides. Now, if we ask you this question on the test, then we're just going to ask you where the error is, right? So you'll have to go through each of the steps and just sort of follow the math, right? Follow the reasoning. Okay, what are we doing here? Is that legal? Can I add 3A? Yes, I can. Add 3A? Yeah. Okay, so this step is good, right? It's true. So 4 times. So what are we doing on this step? Taking out the common factor. So we removed the common factor on each side. Okay, now what are we doing?
Getting rid of
Yeah, so we got this a plus b minus c, so we're dividing both sides. Divide both sides by a plus b minus c, okay, which is common to both sides, right? They both have an a plus b minus c. And that leaves us with 4 equals 3. Is that true? Yeah, we know that. I hope not. I mean, I've gone through life thinking that 4 and 3 were different numbers. So where's the error? What did they do wrong? Because I don't see anything too terrifically unmathematical there. So anybody find the error?
it's supposed to be
Okay, we could flip that around. You could also do it for 1 and 2. You could actually do it for any number. Where's the error? So here's where the error is. Okay, here's the statement, right? A plus B equals C. A plus B equals C. Can I turn that into this? What would I have to do to get A plus B minus C on the left side? Minus C. So I subtract C, I get A plus B minus C equals 0. What are we dividing by? We're dividing by 0. You can't do that. So the error is error dividing by 0. Or let's say error, let's do it down here. Since A plus B equals C, then A plus B minus C equals 0, right? And we are dividing by 0. So any of those proofs that prove one number is equal to another, the error is you're going to be dividing by 0. Error dividing by 0 in, step, in that step. So if it said like circle the error, that's what you would circle. So what are you doing? I'm dividing both sides by 0. Not allowed, right? The 0 is just disguised, right? Because we're not saying 0, we're saying A plus B minus C. But A plus B minus C is 0. Okay, so having seen that, you'll now recognize this on the test, right? You say, it's one of those. We're trying to prove one number is equal to another different number. We can't do that. A father and son arrived at the emergency department at a hospital after the son was severely injured during a football practice. The doctor working in the emergency room went to his admitting station and said to the admitting nurse, "I cannot treat this patient as he is my son. How is this possible?" No. So how is it possible that... So read through this. I'm going to just pause this because, So father and mother create son. Father takes son to emergency room. Doctor working in the emergency room says, "This is my son." So the doctor is the mother. And you're all sexist pigs. In many court cases, evidence is inadmissible due to the evidence being the fruit of the poisonous tree. What does this statement mean? More. If you're going to look it up, I'm going to pause this. Okay, fruit of the poison, the principle that prohibits the use of secondary evidence in a trial that was culled directly from primary evidence derived from an illegal search and seizure. There's an Austrian the exclusionary rule, blah, blah, blah. And if you were watching this online, you could pause it and read it. So it's evidence that has been illegally attained has been illegally. So none of you are taking legal studies, I take it. Well, if you are taking legal studies, then go to class. Guess what we learned in math today? The fruit of the poisonous tree. It's reasoning, right? It's allowing. So that means they have to declare that the search and seizure was illegal, right? That they had no reason to be doing this. Show by performing only one step that there are no solutions to this equation. What is the one step? Subtract 6 from both sides. Okay, so here's the original. And what do you want me to write for the one step? Okay, and we know that a square root cannot be negative. Okay, so a radical must give a positive value. You can actually solve this, right? Because when you square both sides, this becomes 25, and then you get x minus 2 is 25, and x is equal to 23, or whatever. Or 27, rather. But when you put the 27 back in here, you're going to get positive 5. That's a contradiction, right? That's why we do the checking. So that if you actually didn't recognize, if you were just going through the steps, and you didn't say, hey, that's negative, and it can't be negative, I can stop here. And you actually went through the steps, so let's do that just for the heck of it, right? So let's go up here. So x minus 2 is equal to 25, x equals 27, right? And you're happy now. Hey, look, I found a solution. That's why we check. And if we check, root x plus 2 plus 6, or x minus 2. So that's the root of 27 minus 2 plus 6, which is root 25 plus 6, plus 5 plus 6, which is 11. We now have a contradiction, right? We have the left side evaluating to 11, the right side evaluating to 1, so we know that this cannot be true. It's not a true statement, right? There was an error in our solution. Is that it? That's it.